solidifying metal shrank and the exterior of the body broke into faults? Is its surface a combination of iron metal and green mineral crystals, as some iron meteorites are? And what does an impact crater in metal look like? Could its edges or its metal splashes have frozen in the coldest space before they fell back onto the surface? We don't know. So we will take about 4.5 years to fly out to Psyche, launching in 2023. And the mission will orbit Psyche for 20 months, taking images, measuring its magnetic field and its gravity, and discovering its composition. Our team comes from Arizona State University with science co-investigators from 8 additional institutions, and our mission is managed by Jet Propulsion Laboratory, and we are very proud to be the first deep space mission partners with Space Systems Loral, who will build our solar electric propulsion chassis. So we'll fly 2 imagers led by Jim Bell to look at the surface and also get some compositional information. We'll fly 2 magnetometers built by Chris Russell at UCLA and managed by Ben Weiss at MIT, and also a gamma ray and neutron spectrometer led by David Lawrence at Applied Physics Laboratory. And we'll also investigate the gravity of the body using the spacecraft itself with a gravity experiment led by Maria Zuber at MIT. We're going to process and post the images publicly as quickly as we can, in many cases within a half hour. So we'd like to challenge everyone to draw what they think a metal world looks like, and then we can see when the images come back. The mission is designed to learn about planetary interiors, this critical, deep metal part of rocky planets where the magnetic field originates, likely protecting atmospheres and keeping planets habitable. We'll also learn about the early formation of planets, what happened in that high-speed first 10 million years. And finally, we'll look at resources that might be helpful for humans as we explore further and further into our solar system. And by the way, we wrote about this and the science and the Psyche mission in the December issue of Scientific American. Heartfelt thanks, seriously, huge thanks to NASA, to the incredibly hardworking review panels, people who read all 5 of the 1,000-page concept studies, and giant thanks to the Psyche team, which is my favorite, the best team ever. This discovery round had exceptionally high level of competition, all 5 really deserving and compelling concepts, and I think that all of the teams and the hardworking people need to be recognized and thanked for their efforts. Our job is to make the biggest discoveries possible with the investments in space made by Americans, and that's what we're setting out to do. Let me hand it back to you. Thanks, Jim.
Thank you very much, Lindy and Hal. Let me then give it back to Dwayne, but before I do, I want to mention a personal perspective, and that is we're really delighted to be able to have the opportunity to select 2 Discovery missions. Discovery is just such an integral part of planetary science, and these 2 missions are spectacular ones as we move forward. We had a very tough set of decisions to make. We had 5 fabulous proposals, and the program is now back, now healthy, and we're really delighted with the selections that we've made. So let me now turn it back to Dwayne.
Thanks, Jim, and everyone. Operator, we will now transition into the question and answer period. I will now toss it over to you for instructions and the Q&A.
Thank you. At this time, we will begin the question and answer session. If you would like to ask a question, please press star, then 1, and record your name and your media outlet when prompted. Once again, please press star, then 1 at this time if you have any questions. Our first question is coming from Jeff Faust of Space News. So your line is open.
Yeah, thanks. I was wondering maybe for Jim Green, if you can explain a little bit why these 2 missions came out on top, and then because you're selecting 2 at one time, what this means for the cadence of future missions in the Discovery program. Thanks.
You bet. The Discovery program is a competition, and in that competition, we're looking for top science, top scientific implementation, minimizing our technical risk. each of the principal investigators have a cost cap they must be able to stay under, and all these factors are folded into a comprehensive evaluation. It would be wonderful if we could have selected more than two. But of course, obviously, we're delighted with the two selections and our ability to move forward with two. Our budget in the past hasn't enabled us to always do that. The last discovery call, we were able only to select one, which was Insight. So this means now we're going to try to get the program back into a cadence that's much like what was recommended in the planetary decadal. We're probably on the order of 32 to 36-month cadence.
Next question, operator.
Thank you. Our next question comes from Alan Boyle of GeekWire. So your line is open.
Hi. Thank you for taking the question. I wanted to ask, relating to Psyche, whether there were any implications for folks who are interested in asteroid mining. What sorts of insights might be gained for people who want to take advantage of those resources in the future?
Thanks for that question. Yes, I'm really excited about this. Actually, it's turned out to be more timely even than we expected. I think the most important things we're going to discover are what are the surface conditions of a metal asteroid like? What might landing challenges be? What is the topography? Is it covered with some kind of regolith, or is it actually a smooth and hard surface? We don't really know how metal forms a regolith or what happens with chunks of material after they're excavated by crater forming. And so I think all those kinds of information are going to be critically useful, along with better observations from close up of the recent results from Vishnu, so Shepard and his team, looking at the surface of the body and finding potentially some minerals that might hold water viewed here from Earth. And so if we go there and we discover that it's easily mineable and it has mineral resources that can be converted to water, then Psyche could be the perfect stepping stone to the outer solar system.
Thank you. Our next question comes from Frank Mooring of Aviation Week. Your line is open.
Thank you. Maybe this would be best for Jim. I'm trying to get a better take on the spacecraft. Dr. Elkins-Tanton mentioned that Space Systems Loral is doing the bus and solar electric propulsion for Lucy. What is the mass of each spacecraft, and is there SEP, and who's building Psyche? I'm sorry, I got those backwards, but...
Yeah, really, that's for Lindy.
Right. So correct, that was backwards. Space Systems Loral is building the bus and the solar electric propulsion system for Psyche in conjunction with Jet Propulsion Laboratory.
And the other spacecraft, please?
Our spacecraft, this is Hal Levison, is being built by Lockheed Martin, and its wet mass is around 1,435 kilograms.
Do you have SEP?
No, it's a chemical mission, standard chemical mission.
Thank you.
Thank you. I would now like to turn the conference back over to Dwayne Brown.
Thank you, operator. Ladies and gentlemen, we're now going to transition over to social media. We have a number of folks out there very interested as media. So let me turn over to my colleague, Jason Townsend, on social media questions.
All right. This first question comes from Twitter user Captain Video, who asks, with Dawn at Ceres, why were 2 more asteroid missions chosen over a return to Venus?
This is Jim Green. You know, as I mentioned earlier, the Discovery program is competitive. And when we issued the announcement of opportunity in 2014 and received a set of proposals, we received 28 proposals. We down-selected those to the top 5. And in that top 5, indeed, was 2 missions to Venus. Unfortunately, these missions did not receive the level of evaluation that the top 2 missions that we selected. I will point out that in our next call that is currently out on the streets right now, the New Frontiers call does indeed call for a focused science mission to Venus.
All right, this next question comes from Twitter user Ben Mahon, who asks, will the new Discovery missions, Lucy and Psyche, have the ability to visit other bodies in Jupiter's orbit after their primary missions?
I think if they're talking about Jupiter, that must be for Hal.
Yeah, I guess I'll take this. Again, this is Hal Levison. Yes, the spacecraft is designed to, with enough margins, that at the end of mission, we should be able to do another loop, at least, of the solar system and visit several objects and fly by them and study them. There are several Trojans on our list. There are several main belt objects on our list. Interestingly enough, and I've never told you this, Lindy, including Psyche.
Oh, you're serious?
I am serious. So, I have to say, right, the primary idea is to study these objects, which were carefully chosen to reveal as much as we can about the history of the solar system. But we should be able to do more at the end if, NASA agrees or is interested.
Yeah, thanks, Hal, for saying that, because indeed these missions are selected for their primary purpose. And indeed, they're being designed to be able to accomplish just exactly what they have proposed. It's always been wonderful for us in the past to then have an opportunity to look at missions that have completed their prime mission to determine if they're healthy enough, have enough fuel to go to different places or continue to perform additional science that furthers answers the questions that they uncover in their investigations. But that is a completely different process. So once again, we're approving these to move towards flight under their primary objectives.
This next question comes from Twitter user Marson, who asks, will the Lucy mission do flybys or plan some more extended observations of the Trojans it visits?
Lucy is a flyby mission. If you think about it, this fits in with NASA's sort of history of exploration. First you do flybys, then you do rendezvous, then you do landings. And so in order to cover, in our case, in order to cover the diversity that we need to cover, we need to move quickly through the Trojan swarms to cover a lot of real estate. And that means that we are doing flybys only.
Wonderful. This next question comes from Twitter from a high school science class in Delaware who asks, how will the Lucy project help to answer questions about the origin of planets and our solar system?
Well, that's an excellent question. And the answer to that question is it depends on what we see, right? These objects are totally unknown. Not only are they unknown because we've never really visited them with spacecraft, unlike almost every other small body population in the solar system, these objects do not contribute to the meteorite record on Earth. Comets, main belt asteroids, near-Earth asteroids, all are contributing, but not to Trojans because of their proximity to Jupiter's orbit. So I could come up with some stories of what I think it will tell us. For example, we expect, if our theories are right, that we will go to these objects and the old craters will be different colors than the young craters. And that will tell us something about how the asteroids moved around before they were embedded in the Trojan swarm. But that's just a guess, right? This is a mission of exploration, and I think we're going to be surprised by what we see.
Thank you, Jason. And before we go back to the phone lines and to the operator, just a reminder, send those questions in, #AskNASA. Lots of interest, lots of conversation, and we will have an event following this for social media to answer as many questions as we can. So, operator, back to the phones, please.
Thank you. Once again, if you'd like to ask a question, please press star, then 1, and record your name and your media outlet. Again, if you have any questions, please press star, then 1 at this time. Our next question comes from Mike Wall of Space.com. Sir, your line is open.
Okay. This one's for actually Jim Green. I just had a question. I mean, NeoCam gets an additional year's worth of funding. Could you just sort of just kind of explain what that means for that concept going forward? Do you intend encouraging them to sort of reapply for another discovery call, or where does that put that mission concept?
Yes, be happy to answer that. The Discovery Program selection of NeoCam for an extended Phase A effort is really an acknowledgement that even though it was not selected for a full, complete implementation, we want them to address issues that were identified in the discovery evaluation process, and they'll have funding only for the next year to be able to do that.
Thank you. Our next question comes from Sarah Kaplan of Washington Post. Ma'am, your line is open.
Hi. Actually, my question was already asked, so I'm good to go. Thank you.
Thank you. Our next question comes from Kenneth Change of New York Times. So your line is open.
Hi, thanks. Just to follow up on NeoCam, how much money will they get? And is there any way that after a year that if they answer all the questions that there could be any money for them to fly?
Yeah, this is Jim Green. The next stage of the activity is indeed going through the debriefings, and after the debriefing, we'll work and negotiate with the NeoCam project to be able to determine a cost estimate for this next year's worth of work. Once again, this mission is an important capability for the agency, and we want them to complete this formulation process during this extended Phase A and answer all the associated questions that we have for them.
Thank you. Our next question comes from Ken Kramer of Universe Today. So your line is open.
Hey, thanks for taking my question, and congratulations on the 2 selections. My question for Hal Levison is, I think you mentioned you're going to use chemical propulsion. I'm kind of curious, did you consider ion propulsion at all, and why you didn't use that? And for Jim Green, can you give us an update, please, on InSight and the fixing that science instrument? And is it going to launch on time? Thanks.
Yeah, I'd be happy to start that. It turns out that the chemical propulsion is the correct way to do this, simply because we need to, again, have these large velocities with respect to the Trojans in order to cover a lot of real estate. So essentially what we're doing is we're launching into an orbit that's almost 1 year, and then we use gravity assists with the Earth to slowly pump up the aphelion distance of the spacecraft until it gets to the Trojan swarms. So as we go through the swarms, we're actually on a fairly eccentric orbit with an aphelion near Earth and an aphelion near Jupiter. And the chemical propulsion really is just after the launch and get us into this orbit, simply a correction on what the Earth encounters are actually going to give us.
This is Jim Green, and I'll answer, Ken, your second part of your question about InSight. What we're doing right now is requalifying the hardware. Everything looks great. It's on track. The Kness is completing the redesign and refurbishment of their instrument that will then also meet the NASA process called ATLO. The ATLO part of our process starts in July of 2017, and then the launch is in May 2018. And right now we're on schedule, and everything's looking fine.
Thank you. Our next question comes from Danica Worthington of Denver Post. Ma'am, your line is open.
Hi. I may have missed the latter end of this question and only heard the latter end of it during the Star 1 process, but just in case, I know both projects are capped at $450 million, but is it possible to get the individual cost of each?
Is that a Jim Green question?
Yeah.
This is Dwayne Brown. We'll get you those numbers. Just send me an email, and we'll track it down. We'll make sure we give you the accurate numbers.
Thank you.
Okay, so what I'm going to do, operator, we're running good on time here, so we're going to go back to social media, and then we will go back to the calls and wrap up. So back to our social media manager, my colleague Jason Townsend.
Sure. This question comes from Twitter user Void Shaper, who asks, can you give us details on the payloads on both missions?
Sure. Shall I start out first? On the Psyche mission, we are going to fly imagers with filter wheels so that we can get images at specific wavelengths to look at composition, and those are led by Jim Bell and in conjunction with Malin Space Science Systems. And then the gamma ray and neutron spectrometer comes from Applied Physics Laboratory, David Lawrence leading. The key thing here is that to measure compositions of metal, a normal vis near IR spectrometer is not going to really help us there. We really need the gamma ray spectrometer. And then magnetometers, we'll put two of them on a boom in a gradiometer configuration so that we can get sensitive measurements. It's possible that if Psyche is made of material that's as magnetic as the most magnetic iron meteorite samples that we have, that it could originally, when it was an active dynamo, have had a magnetic field the size of a third or a half of the Earth field. And now that would be not in a dipole. It could be in a very complicated and much weaker configuration. So the two magnetometers and a gradiometer configuration will help us to measure that. And then we'll do gravity using radio science and the spacecraft itself. Oh, and I should say, we would like to fly DSOC, the Deep Space Optical Comm NASA test instrument, and we're very excited to take that out to just past 3 AU.
Okay, Lucy has 3 instruments. The first is a high-resolution panchromatic camera from the Applied Physics Lab. This is an activity that's headed by Hal Weaver. This is a camera that's based almost an exact copy of the panchromatic camera that's on New Horizons. We also have a color imager and near-infrared imaging spectrometer from Goddard. Dennis Reuter is the head of that, and it is a close copy, although there's some significant differences there, to the Ralph instrument that's aboard New Horizons. And then we have a thermal infrared spectrometer from Arizona State University, which is an exact copy of one that's on OSIRIS-REx. By Phil Christensen of Arizona State.
All right, there's a couple of different questions here from users asking about how they can get involved with these missions. One comes from Twitter user Joe, who asks, will there be any public input on these 2 missions? And Twitter user Philip asks, will there be any internship opportunities for undergrads to participate?
You want to go first, Hal?
Sure. We are in the process of discussing with NASA the idea of having student input into the mission, although we don't have anything firm at the moment.
And so for Psyche, we are definitely going to have a very significant student part. We already have plans in place for student team activities during cruise and when at Psyche, and we are working on plans to get people involved much earlier, and there will also be internship plans. Nothing is completed yet. We need to have further conversations with NASA to make sure that our plans are exactly in line, and we will be posting announcements, so please look out for that. In line with the mission at ASU, we are very, very interested in making everything as educational a process, mixing education and research together and getting as many people involved as possible. And so there will be quite a number of opportunities. I'm sorry I can't be more specific now, but keep your eyes out.
All right, wonderful. This next question comes from Twitter user Emily Lakdawala, who asks, does selection of 2 long timeline missions put long-term pressure on the Discovery budget?
Yeah, thank you, Emily. It's real important to understand that when we talk about our programs, we're really talking about a series of missions. These two missions are phased with Lucy going first and then Psyche going later, such that the overall budget, as we look at those two and add them, ends up at a rate that not only we can afford, but we can project into the future as part of the program. That's the important element of the program. And because the development cycles on these are much shorter than our larger strategic missions, we need to be able to create a pipeline or a series of missions to be able to keep the program at an approved and specific level and be able to manage the budget appropriately over time.
Okay, operator, we are now going to go back to the phone lines, and if you can repeat the instructions, please. Thank you.
Thank you. Once again, if you'd like to ask a question today, please press star then 1 on your phone and record your first and last name along with your media outlet. Again, please at this time, if you'd like to ask a question, press star then 1. Our next question comes from Matt Williams of Universe Today. So your line is open.
Thank you. My question is for Lindy. I want to ask, you mentioned how planetary interiors, the connection to how studying Psyche will tell us about where magnetic fields originate. And what occurred to me was, will this shed any additional light on the questions of how Mars lost its magnetic field?
Oh, that's so interesting. I sure hope so. I sure hope so, but it's not clear to me exactly what that path will be right now. It's hard to know exactly what we're going to learn about dynamos until we're there, but we're very hopeful that this could be among the most magnetic objects ever visited, and indeed the first dynamo that we could, in a sense, dissect. Another thing that we might learn about Mars and other rocky planets is what kinds of materials were carried into the growing planet by the core. And we think of Earth's high-temperature, high-pressure core as being less than 10% elements that are not iron and nickel. So it's over 90% iron and nickel and almost nothing else. But these small cores in the baby beginning planets could have carried, in fact, carbon and even hydroxyl or hydrogen into growing planets. They could actually be a route for habitability, and so Mars, with its smaller size, may be in fact closer to Psyche than the Earth. And so it's all a continuum, and we're hoping that we're going to help fill in some of those gaps.
Thank you. Our next question comes from Paul Flav of Texas Public Radio. So your line is open.
Thanks. My question's for Hal. I was just wondering, you touched on it a little bit, but can you elaborate on why the Trojans versus some other asteroid belt will give special insight into the origins of the solar system? Is it the variety and their proximity to one another, or what is it that makes them more special for the information you're looking for?
So if we look, through the outer solar system, right, you have the 4 giant planets and basically nothing else. So these objects represent, a population that is now gone, right, that they went into growing the 4 giant planets and have been removed by the gravitational influence of those 4 giant planets. So this is really a unique population that samples this region of space, and there's no other population that really, particularly that we can get to with the spacecraft, which will allow us to study those types of objects.
Thank you. I will now turn the call.
Thank you, operator. Folks, I believe we are going to be wrapping up, but before we do that, we do have one question that if Thomas is still on, I know he just landed from a flight and is on a cell phone, but Thomas, if you're on.
I am.
Yeah, if you would care to answer, I think you're going to like this question, and I think we could also, if you want to close out with any remarks. But Jason, the question, please.
Sure. This question comes from Twitter user Luis, who asks, which mission is NASA more excited to progress on, and why?
That's a good one. Look, the way I looked at it, so first of all, I mean, most of you know that as far as discovery is concerned, I spent a lot of time of my life on a discovery mission, namely Messenger, and I know how life-changing it has been for me and my students when I was a professor at the University of Michigan. I also know how much dedication it will take for both of those teams to do that. So when I looked through, listened to all these finalists, and I just was reimagining what the future would look like. Where are the textbooks going to be rewritten? What are the opportunities for us to really learn? So for me, the way I think about Psyche and Lucy is really, two chapters of a storybook of the early solar system. And so for me, I really looked at them in many ways, very complementary to each other. So I'm going to punt on the question, not because I somehow can't take sides. It's just because, for me, they really belong together. And so for me, having the ability of doing, because of the budgetary layout, having the ability of selecting both was really just a dream come true. And my hope is that, as we look back at this, a few years down the road, that we will all, really see the opportunities for learning and just the great discoveries that will come from both of these missions. So thanks for everybody's attention. I'm going to dial off, jump off at this point and do my next thing. Dwayne, is that okay?
Yes, sir. Thank you, and
all right.
Have a good conference down there.
All right. Thanks so much.
And Jim Green, did you?
So I would, too, also like to comment on the question about which one of these missions I like the best. As the Director of Planetary Science here at NASA, and we have just a full range of missions, I really have to tell you I love all my children equally. And so I'm very excited about both these missions. As we talked about today and is really quite clear, these are missions of discovery. They're going to return spectacular results. They're going to probe some unknown areas that we are just pretty clueless about. Even though us as scientists think we know everything, we really don't. So thanks, and let me turn it back over to Dwayne.
Well, I want to thank Thomas and Jim and the principal investigators. And I actually want to give a special shout-out to Lori Cantillo for her fantastic work, the entire Science Mission Directorate team, OCOMS, for the prep work over the holidays. Santa Claus was not happy, but and congratulations again to the selectees. And, of course, all of the missions like these and all in the Science Mission Directorate portfolio are available on the web, www.nasa.gov. Send in your questions. We're going to get to them. #AskNASA. The community and the conversation is vast and excitement. And finally, while things are ever-changing, one thing will remain infinite. Science never sleeps. Back over to you, operator.
Thank you. This concludes today's conference. You may all disconnect at this time.